There is a rod in our hand and we just left it. It is falling down. So there is a motion in a rod. Now we know that due to earth there is a magnetic field here. Let us say at this place the direction of magnetic field is inside this way and the rod is falling down. Velocity in this direction. Okay. Now this rod has got many free charges in it, free charge particles here, free charge particle. These are in magnetic field and when it falls down, the charges are also falling down. These charge particles which are falling down, they are in a magnetic field. And here we have studied, if a charge moves in a magnetic field, it experiences a force. So all these charges are experiencing force because they are moving in a magnetic field. Now, if they are experiencing a force, you know that force F is equal to QVB. Then there is a direction of the force. What is direction of that force? That is given by Fleming's left hand rule. What does it say? It says that if there is a magnetic field in this direction and we give velocity to the charge in this direction, then the charge will experience a force in this direction. This I apply here. The magnetic field is inside, the magnetic field B is inside. The velocity is downward, inside, the velocity is downward. This is direction of the force. So all these positive charges gather here and all the negative charges will experience force and gather here. You see, here negative charges, here positive charges assembled. So there is a difference of the charges, positive here, negative here, and that creates here an electric field and that creates the potential difference. So a potential difference is created here, EMF. This is what Faraday says induced EMF, because the flux linked to this is changing. So whenever a conductor is moving in a magnetic field in such a way that magnetic field, velocity and length of the conductor, they make right angle to each other, then an EMF is induced in it. And this EMF is across these two. Now if I complete the circuit, if I complete this circuit, what will happen? These positive charges will go here and this will be the direction of the current in it. This is direction of the current. This is direction of the current. Now this direction of the current, we can very well find it with another rule. And that rule is Fleming's right hand rule. Here when we are applying force, to find force on moving charge particle, apply left hand rule. In this left hand rule, what is given to us? The answer is B given, V given, find F on charge. Okay, now there is another exercise to find current in a moving conductor in magnetic field. Use Fleming's right hand rule. Yes. Why right hand rule? In this, B given, F given, find direction of current. And what is current? Current is drift velocity of the charges. Drift velocity of the charges. So here F is given, we have to find drift velocity. Here V is given, we have to find force on the charge. So when V is given and we have to find force on the charge, we use left hand, and when force on the charge is given, that means force on the conductor is given, we have to find direction of current, then we use right hand. This is electromagnetic induction. This is Lorentz force. So remember when you have to apply left hand and when you have to apply right hand rule. When you want to find out current, right hand rule. When you want to find out force on the conductor, use left hand rule. B in both the things are given. Okay. Now again we come back to motional EMF. This is how much is the quantity? We want to find out electric current in this or EMF. If this EMF is equal to, we have already done the calculation in the previous lecture, that if a conductor of length L is moving with velocity V in a magnetic field of strength B, then EMF induced across is B into L into V. So this is EMF induced across this, a falling one. And if we complete the circle, then the current will flow. And this current you can find out by this rule. Apply this rule. Let us do here. This is the magnetic field going inside and the force is given by the thumb. Force is given by the thumb and that is downward. What is the direction of the current? This is direction of the current. So the current goes from here, 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 this way. So this is direction of the current. This I, this I, this I, and this I. This is the direction of the current. Sometimes we are asked, what is direction of EMF? Whether this will be plus or this will be plus. We have just seen that this is plus. But sometimes you say that how the current is flowing from minus to plus. That is not allowed. Okay, you say that is not allowed, but I say it is allowed. How come? Here is something you must remember in case of source of EMF. Source of EMF. What is source of EMF? A cell. This is plus, this is minus. Now I complete the circuit here and switch it on so that the current start flowing. The current start from the positive to the negative terminal here. But what happens here? Does the current stop here? We have learned no. Current is a continuous circuit, otherwise it cannot flow. It has to be a complete cyclic motion of the charges. That means current is flowing here also, inside the cell. Now, inside the cell, what is the direction of the current? Plus to minus or minus to plus? Yes, you are right, it is flowing minus to plus. So, inside source, minus to plus. Outside source in the circuit, it is plus to minus. This is current rule. Please remember, and not that way that it flows from positive to negative. Positive to negative is absolutely correct when we have come out of this source. It is pushing the charges from positive to negative, but inside the source it is minus to plus. What is inside the source? Who is the source? Who is giving energy and power to the charges? That is the source. Now, when this rod is falling down, in the magnetic field, then there is a force on the charges, and all the positive charges have gone to this corner, negative charges to this corner, and we are asking what is polarity of current. The current flows from positive to negative in this way, because this is the circuit. If we complete the circuit, then only current flows, otherwise current will not flow. There will be a conductor here, this side is positive terminal, this side is negative terminal, that's all. All the positive charges are here, negative charges here, no current. When the current will flow? When we put a load and complete the circuit. Now current will flow like this. Here, 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 and here, this way. You see, outside plus to minus, inside minus to plus. So, if it is a source, if this is the source, this is the source. Why? We are moving this, EMF is induced across it. And whenever this is the agency of EMF, this is agency of EMF. So, it acts like a cell. It acts like a cell. And in the cell, current flows from minus to plus. Therefore, if you are able to find out with help of right hand that the current here, this is magnetic field, this is the force downward, this is direction of the current, this is direction of the current, then be sure this is minus, this is plus, because inside the cell it flows from minus to plus, and this is acting like a cell. If you complete the circuit, outside it is plus to minus. Then this has become a very important question asked in very competitive exams, like exactly like this. A rod is falling and the rod is kept in east-west direction. The magnetic field of the earth is south to north and it is falling down. Then what is the polarity of the charges in this rod? Which side, eastern or western, will become positive, which will become negative? So our answer is this eastern side will become positive and this will become negative, because inside the rod the current has to flow from minus to plus, and this gives that current is flowing from west to east inside the cell. This is how you find the direction.